Okay, so we're going to start from the pH scale. Okay, and just remind ourselves what the pH scale is. Okay, so I showed you this slide, and we said that the pH scale goes from a high of 14, where those things are more basic, and then all the way down to something like 0, which would represent a very, very acidic thing. Closer to 1, really, closer to 0 would be more acidic. Okay, and so we can point out a few things here. Remember that your pH scale just means minus the log of H3O plus, whichever way you want to look at it, but it just means minus log. Any P scale just means minus log. Okay, and remember to undo that. So say if you wanted to, for instance, find the concentration of H3O plus, you would just take 10 and raise it to minus pH. Since you're taking minus log, you would raise to minus pH. Okay, and that will give you the concentration of H3O plus, or in other words, H plus. Okay, and if we look at the scale, just looking at some things that are acids and bases, so starting at the top, close to 14, you have sodium hydroxide. Okay, that's a very strong base, one of the strongest bases, very common in labs, so that's one you've worked with. Dropping down, you have something like ammonia, magnesia, things that you would maybe use for acid relief, like Tums or something like that. These will all be basic bases. Okay, baking soda. Okay, human blood is pretty much neutral, along with pure water and milk. So those are kind of your neutral things. Okay, moving down towards the acidic side, you have black coffee, tomatoes, wine, vinegar, obviously. Acetic acid is a weak base. Lemon juice, sweet acid, and then your hydrochloric acid, HCl. Okay, so that kind of should give you an idea of some of the common things you used in the lab that are acids and bases. So remember, anything above a pH of 7 will be basic. Anything at a pH of 7 will be acidic. Okay. I'm sorry, anything at a pH of 7 will be neutral, and anything below a pH 1.0 times 10 to the minus 7. So notice it's less than now. So it's talking about actual H plus concentration. So if we have a basic solution, your H plus will be small. And if you have an acidic solution, so we have H3O plus concentration greater than 1.0 times 10 to the minus 7. Okay, so lots and lots of H plus around. And if we're in a neutral solution, it'll be about equal to 1.0 times 10 to the minus 7. And those are all molarity. Okay. So we worked this problem out. Okay, so we have a hydronium ion concentration for lemon juice is approximately 0.0025 molar. And it wants us to say what is the pH when H2O plus concentration is equal to 0.0025 molar. So in other words, what's the pH of lemon juice? Okay, so remember to find a pH. You're just going to take the minus log of the H3O plus concentration. Here they were nice enough to just go ahead and give us that. Okay, so all we have to do is take the number they gave us and take the minus log. So you just punch that into your calculator, and you get a pH of 2.6. Okay, and you can kind of do a rationale check here. So we're talking about lemon juice, which should be acidic. We've got a pH that's lower than 7, which would be acidic, and in fact is pretty close to 1. Okay, now lemon juice is a pretty strong acid, so this all makes sense. Okay, just to remind you, when you're talking about sig figs for p scales or taking the log of something, you're going to keep the same number of significant figures after the decimal, okay, that you had in the original number. So in 0.0025, there are 2 sig figs, just the 2 and the 5. Okay, so we use 2 sig figs after the decimal. I don't know if you can see my mouse or not, but hopefully you can. Okay, that's really the only way I have to point to the slides, as I would usually use my laser. Okay, so again, 2 sig figs in our number, so keep 2 decimal places in your answer. Okay, so here they want us to calculate the pH of an aqueous ammonia solution that has an OH concentration of 0.0019 molarity. Okay, so we want to know pH, not POH. If we wanted POH, we could just take that number. What we actually want is pH. So remember, to jump to our equation where we have H3O plus is equal to 1.0 to the minus 14 molar squared over the OH concentration. So that's just saying that, remember your equation is H3O plus concentration times OH minus concentration is equal to 1.0 times 10 to the minus 14. So you can rearrange that equation to set it up like this. Okay, so that will actually solve for the H3O plus concentration. Okay, so now once you have the equation set up, you just plug your numbers. So you just have to divide 1.0 times 10 to the minus 14 by 0.0019 molar. Okay, and that will give you the H3O plus concentration. Okay, from there you can put that into your pH equation, just take the minus log of it, and that will give you the pH. And here they said aqueous ammonia solution, which should be basic, and we get a basic pH, so that makes sense. Okay. So I think we're coming up here to about where we left off. That looks correct. Yeah, so we got a couple more slides here. So we were back where we actually stopped, if you can remember back that far. Okay, so we're talking about acid rain now. So acid rain, it says, is a matter of serious concern, but most species of fish die in the waters having pH lower than 4.5 to 5.0, and they want us to calculate the H3O plus concentration. The lake has a pH of 4.5. Okay, so here we need to undo pH. They gave us a pH. Okay, so we're going to take just 10 raised to the minus pH, and that will tell us our H3O plus concentration. So here we had a pH of 4.5, so 10 raised to the minus 4.5 will give us our H3O plus concentration. So you can see that there. I know I'm moving a little bit quickly through this, just because we already went over it. I'm just trying to remind you what I talked about. Okay, so remember that the P really just means minus log of whatever we're talking about. We could have POH, PKW, P of anything, doesn't matter. Okay. So we left off on this slide. Okay, so setting up this equation. Okay, so if you remember, we talked about KW. So KW 1.0 times 10 to the minus 14. Okay, so this number. Okay, so we set up this equation. So H3O plus concentration times the OH minus concentration is going to be equal to KW. So if we take minus log of both sides, okay, so in other words, take the pH, the POH, and then take the minus log of KW, okay, what we end up with is pH plus POH is equal to 14. Okay, so the 14 comes from just taking the minus log of this guy. So you'll notice that anytime you take the minus log of a number like this, you end up with this as your answer. You end up with, like, for instance here, 14 as your answer. Okay, so this gives us another way to manipulate pH and POH. So don't get confused here. So remember that if we're talking about concentrations, we're multiplying. Okay, but if we're talking about pH and POH, we're adding. Okay, so don't get those two equations mixed up. Okay, so we can say pH is equal to 14 minus POH, or you could flip the equation around the other way. Okay, so question here. So it says, what is the pH of a 0.025 molar solution of HNO3? Okay, so we have an acid, and they want us to tell what is the pH. Okay, and they give us this equation. So we say that NO3 plus water, so in other words, we're putting the acid into water, and it says that it 100% dissociates into H3O plus and NO3 minus ion. Okay, so your nitrate ion. Okay, but what they want us to calculate here is what is the pH. So they're giving us this equation just so that we understand that it's completely dissociating. We'll look at why that's important in a little bit here. Okay. So suppose we want to know the pH of this, we would just take the concentration they gave us, take the minus log, okay, and notice that here again they're telling us this is a strong acid, so it completely dissociates. So all we have to do just take the minus log of the H3O plus concentration, okay, which gives us a pH of about 1.6. Here we know it's an acid. It's a strong acid. It's one of your strong acids. Okay, so we get a acidic pH, so that makes sense. That's good. Okay, but suppose we had something different. Suppose we had a base, a strong base, in fact. Okay, so suppose we wanted to know the pH of 0.025 molar solution of sodium hydroxide. Okay, so we have NaOH, sodium hydroxide. I'm going to say it 100% dissociates into sodium ion and OH minus ion. Right? But remember, we want pH, so we have to first find the H3O plus concentration. What they've given us here is a strong base, so that means that the OH minus concentration will just be equal to the amount of the base you put into solution. Okay, this won't be true if we're not talking about strong acids and strong bases, but since we're talking about a strong base, and in the last problem we talked about a strong acid, we can just assume that the OH minus concentration is equal to however much sodium hydroxide we put in. Now, if we had a weak base, this wouldn't be true, but since we have a strong base, it is true. So we can set up this equation. We can say that H3O plus concentration, because remember we're trying to find pH, is equal to 1.0 times 10 to the minus 14, and that's going to be in molar squared since we have molarity times molarity. And we're going to put that over the OH minus concentration, and that will tell us H3O plus concentration. And remember, again, this OH minus concentration will directly come from how much base we actually put into the solution, okay, because this is a strong base. If it's not a strong base, we can't do that. So now all we have to do is plug in our numbers. Okay, so that gives us an H3O plus concentration of 4.0 times 10 to the minus 13 molar. Okay, then again, we want to know pH, so we just take the minus log. Okay, so 12.4. And we're talking about a strong base, so we get a basic pH. Okay, so that all checks out and that makes sense. Okay, so another way you could do this is you could find the POH, since we have that equation as well. So we could just take the POH, in other words, take the minus log of the OH minus concentration. Okay, and that would tell us the POH. And then we know that pH is equal to 14 minus the POH, and that just comes from our equation before. Okay, go back if you need to. So we can just say 14 minus our POH will give us our pH, which gives us the same answer. Okay, so you could do it either way. So you could either convert to H3O plus concentration initially, or you could just take POH and then convert to pH from there. Either way, it would work just fine. Okay. So here in classes where I would normally pause and give you some time to answer these, so I would encourage you to do the same thing with the video lecture. So I would encourage you to read the question. So pause the video, read the question, and then go through it. I'm also going to work it out just as I would in class. Okay, but I would encourage you, just as you would in class, to take this time to actually try the problem. So we left off with this problem. So hopefully you've worked it out by now. And I'll go over the solution. So just like in class, I'll have some that are typed in the slides. Other ones I'll handwrite for you so that you can see them a little bit better. I know sometimes that's a little bit easier than actually having it typed in, but it's easier for me to have it typed. So, okay. So the first question I ask, what is the pH of a 0.0012 molar HCl solution? Okay, so first thing you have to identify is you want to know that HCl is a strong acid. Okay, hopefully you just know that. Make sure you have all your strong acids memorized. Make sure you have all your strong bases memorized. And everything that's not one of those strong acids or bases, remember that's going to be a weak acid or a weak base. Okay, so the first one, HCl, we know is a strong acid. Okay, so we can assume here we're looking for pH. So what are we really looking for? We want to know the concentration of H3O plus or H plus. Okay. So they tell us in the problem, concentration of H3O plus is 0.0012 molar. Okay, so all we need to do is just set up our pH equation, which remember pH is just the minus log of H3O plus. Plug in the number they give us. Okay, take the minus log of the concentration they gave us. Okay, boom. So you get pH of around 2.92. Okay, and just do a logic check. We know that HCl is a strong acid, so the pH should be low. 3 is pretty low, so likely answered the question correctly. Okay, the next one, they want to know what is the pH of a similar solution, but this time we have sodium hydroxide. So again, first thing you have to know is that sodium hydroxide is a strong base. So then you can assume that the OH minus concentration is equal to the concentration of the base. So we set up our POH equation. Okay, so you can do it this way, or you can do it the other way, which I showed you. So POH is equal to the minus log OH minus concentration. So find the POH, and then set up your equation to convert POH to pH. So that's what we're looking for. Okay, so pH is just equal to 14 minus POH. So plug that in, and you get 11.08, which is the basic pH, and we're talking about a strong base, so that all makes sense. Okay, feel free to email me if you have questions about any of these, by the way. I'll try to get back to you as quickly as I can. Okay, so here's the next problem. So again, just like we were doing in class, it would be good for you to pause the video here, work out the problem, and then watch me work it out and see where you went right and where you went wrong. Okay, so I'll give you a few seconds to pause the video now. Okay, and then while you're doing that, I am going to switch over to my doc cam. This is what crashed it last time. Hopefully this works. Okay, so you should be seeing my paper now as far as I know. The first part of the question asks us, if the pH of a diet soda is 4.32 at 25 degrees C, what is the H3O plus concentration and what is the OH minus concentration? Okay, so we are going to, I'll first rewrite some of the key information out. So there's a little bit of a delay with this camera setup, but hopefully it will work out for us. If not, I'll figure something else out, but this should work for us. Okay, so they tell us that the pH is going to be equal to, off the page there you go. pH is equal to 4.32. Okay, and they tell us that's at 25 degrees C. Not really relevant, but we have that information. And what they want to know is what is the H3O plus concentration and what is the OH minus concentration. Okay, so the first thing we have to do is we need to know our definition of pH. Okay, so remember pH is equal to minus the log of H3O plus concentration. Okay, so with that, we have a lot of information. So you can either rearrange this equation and solve for H3O plus concentration, or just based on this knowledge, we know that if we raise, so the H3O plus concentration will be equal to 10 raised to minus the pH. Okay. And if you have trouble remembering that, if you on your calculator, the button that undoes a function is almost always given as the secondary function. So here's log, and it's probably hard for you to see, but just above it, it says 10 to the x. Okay, so that's going to undo log, in other words. Okay, so our H3O plus concentration becomes 10 raised to the minus 4.32. That was just given from the problem. Okay, so solving that, I get, so 10 raised to minus 4.32. I end up with 4.79 times 10 to the minus fifth. Okay, so the answer is part of the problem. So now we've done this part. Okay, but we still want to know what is the OH minus concentration. Okay, so remember, we have this equation. Try to slide up a little bit. So Kw is equal to OH minus concentration times H3O plus concentration, or you could write it the other way around. The same since we're doing multiplication. That's a W. Okay. So we can just plug in the numbers that we know now and solve for OH minus concentration. Okay, so rearranging this, just divide both sides by H3O plus concentration. So what we end up with is Kw over H3O plus concentration will be equal to the OH minus concentration. Okay, so now we just have to plug in our numbers. Remember that Kw is equal to 1 times 10 to the minus 14, and that's molarity squared, since we have molarity times molarity. Slide up again. Okay, and that's going to be over the concentration we just found for H3O plus, which was here. So 4.79 times 10 to the minus 5. And that's going to be equal to our OH minus concentration, okay, which will be equal to 2.09 times 10 to the minus 10. Okay, so that would be our second answer, second part of our answer. Okay, so that was the first question. So I will switch back to the question just so we can read it together. Share the application. Okay, so you should be seeing the screen again. So in the second part of the question, they want us to calculate the pH, a 0.0050 molar solution of slake lime. And they give us the formula for slake lime, calcium hydroxide, so CaOH2. Okay, so let's switch back now to the camera so that you can see what I'm doing. Okay, so I'll slide this up a little bit. Sorry if you get a little motion sick there. So let's write out what we know. I always like to start from there. Okay, so we're looking at calcium hydroxide, CaOH2. Okay, and they tell us that it has a concentration of 0.0050 molarity. Okay, what we want to know is what is the pH? Okay, that's what we're looking to find. Okay, so they give us a concentration. So hopefully you can recognize that OH, since it has an OH, it's a base. Okay, and they give us a concentration and they want us to find pH. So one thing you may not guess yet on this one is that here we have 2 OH minus. Okay, so that means for every 0.005 molarity, we have double that of OH2, or OH minus, excuse me. Okay, so that means that if we want to calculate our OH minus concentration, it's not simply just equal to the concentration that they gave us. I'll wait for the video to catch up a little bit. Okay, so it's not just equal to that concentration. So what we have to do is we have to calculate it. So we say concentration of OH minus is equal to 2 times, and the 2 times because for every molecule of calcium hydroxide, there's 2 OH minus. So that means it's providing 2 OH minus for every 1 molecule at this concentration. So 2 times that concentration will give us our actual OH minus concentration. Oh, we can forget about the molarity for now. So that means our OH minus concentration is actually equal to 0.01. Okay, we have 2 sig figs there, so we'll keep 2 sig figs. Okay, and that's going to be in units of molarity. Okay, but that's not really what the question asks us. The question is asking us to calculate pH. Okay, so we have to go back to our Kw expression, and we'll say that H3O plus concentration is equal to, it's going to be our Kw over OH minus concentration, which is equal to 1.0 times 10 to the minus 14, kind of running out of room here, over the OH minus concentration that we just calculated, which was 0.010 molarity. Remember, this is molarity squared. Okay, so solving that math, I end up with 1.0 times 10 to the minus 12. And so we're ultimately looking for pH. So we just calculated our H3O plus concentration, but what we're looking for is the pH. So we just need to say pH is equal to minus the log of our H3O plus concentration, which is 1.0 times 10 to the minus 12. Sorry about that. I'm writing in pen, so I can't really erase it. Okay, and if I take that minus log, I end up with a pH of 12. Okay. And we know that this is a base, so having a high pH makes sense to me.